So the first question is, suppose all the terms of an AP are natural numbers. If the ratio of S7 to S11 means S7 by S11 is given as 6 by 11, alright, and the 7 term, that is T7, lies between 130 and 140. So I have to find the common difference of the AP. So S of anything in the suffix means that sum of n terms. So here the sum of first 7 terms divided by sum of the first 11 terms. Alright. So we know the formula, so we can apply it directly. Twice A, if A is the first term, 6D. If D is the common difference, then 11 by 2 of something like 2A plus 10D. Okay, so this 2 gets cancelled. This 11 gets cancelled out. So what we get is, and 2 from both cancels out, right? So we get 7 into A plus 5D divided by A plus 5D. So this is nothing but 3D. Okay, this is 6. Now 6 is 7A, we get A, and 30 minus 21 we get 9. So we get A equal to 9D. Alright. So until now the problem is quite simple. Next part is, so we got A is equal to 9D, right? And the next part is 130 less than A plus 6D less than 140. Just apply the nth term formula. So we get 130 less than A is 90 we got. So 15D less than 140. Now we need D, right? So what will you multiply with 15 to get a number between 130 and 140? Let's try 8. This is 120, so it doesn't work. Let's try 15, 9, 135, perfect. So this means that D is nothing but 9. So this is the common difference of the AP is asked in the question. Alright. Okay, so this is the second question from the topic sequence and series. Let L1, L2 up to L100 be an AP with common difference T1, and there is also a second AP with common difference T2, right? And the product of their common differences is 10. Now consider a rectangle with length Li and Wi, where I goes from 1 to 100, and area Ai, and some data has been given. So how do we approach? First of all, we will consider this rectangle, right? So this is the rectangle. It has width Wn and length Ln. Okay, so I'm basically considering the nth rectangle in terms of the terms, right? So what is the area? An is nothing but Ln into Wn, right? So Ln is nothing but the formula of the first nth term of the AP. So it is nothing but L1. Okay, let me write it again. So it is L1 plus n minus 1 into some D1, right? Into W1 plus n minus 1 into D2. Since number of terms are same in both the AP, so I'm considering n minus 1 and n minus 1. Now I've been given A51 minus A50, right? So I'll first calculate A51 and then A50 and then subtract them. Alright, so what is A51? It is L1 plus 50 D1 into W1 plus 50 D2. Okay, and here it will be L1 plus 49 D1 into W1 plus 49 D2. Now just subtract them. This value is already given to us, right? If you observe, L1 W1, L1 W1 gets cancelled out, right? Next 50 L1 D2, and from here L1 49, so it becomes nothing but L1 D2, right? Next D1 W1, 50 minus 49 is 1, so D1 W1 is also like this, plus 990 you will get, because D1 D2 is 10, right? So 50 square 10, 49 square 10, the difference is 990. So what I'm getting is, I'm getting L1 D2 plus D1 W1 equal to 10. Just subtract from 1000, we will get this. Now we need to find A100 minus A90, right? So I'll rub this question over here. So we need A100 minus A90, which is L1 plus 99 D1 into W1 plus 99 D2, alright, minus L1 plus 89 D1 into W1 plus 89 D2. Now again L1 W1 gets cancelled out, simple to observe. Now this becomes L1 D2, L1 D2, 99 minus 89 is 10, right? L1 D1 plus D1 W1. Next 99 square minus 89 square into 10, right? So this value was 10, I think. So we get 100 plus 10 into 10, 100 into 99 plus 89, right? So we take the 100 common. So 1 plus this thing, that is 189. So the value is 18900. Simple. Okay, I hope you got this problem easily. Let A1, A2 dot 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 be a sequence of positive integers in AP with common difference 2, and B1, B2 be a sequence of positive integers in GP with common ratio 2. If A1, B1 equals C, then the number of all possible values of C for which the equality holds true, right? So what we'll do is, we have this equality, right? So we'll start from there only. First term is A1. What is the second term? So if you write the nth term of the first AP, it is A1 plus n minus 1 into 2, right? And A1 is simply C, so n minus 1 into 2. So if we put 2, we get C plus 2, right? And A1 is simply C, so we get like this, C plus, if we put 3, we get 4, okay, plus dot 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 up to c plus n minus 1 into 2. So this is the first part of the equality, and the second part is this is c, this is some 2c, 2 square c. Just put it in the formula of GP, you'll get this. Simple. 2 to the power n minus 1 c. तो ये आता है इक्वालिटी, राइट. अब इसे जस्ट सॉल्व करना था. इफ यू लुक 2 4 2 n minus 2 means if we take the 2 common from each bracket, you get n minus 1 terms plus this c. So there are basically 2 into nc terms, right, plus 2 1 plus 2. So I take 2 common, 1 2 3 up to n minus 1. Alright, और यहाँ पे c कॉमन ले लो तो ये आएगा 2 to the power n minus 1. सिंपल. GP का सम है कि नहीं. So I'll rub the question over here and take out some space. So what did we get? We get 2 into nc plus 2 into मतलब n into n minus 1, right? सही है ना? So we get this, which is equal to c into 2 to the power n minus 1. Alright? अब हम लोग क्या करेंगे? ये 2n को c के साथ क्लब कर देते हैं. So 2n into n minus 1 equal to c common 2 to the power n minus 2n minus 1. Right? So get c as 2n into n minus 1 divided by 2 to the power n minus 2n minus 1. Now कितने वैल्यूज आएंगे c के कि ये रेशियो इंटीजर हो. n equal to 1 आएगा, 2 आएगा, 3 आएगा, right? So you can check it. After some values it will not be any more integer because 1, the denominator will be greater I think than the numerator. I hope you enjoyed the problem.